So we know how to find the circumference of a circle. We know how to find segments of the circumference. How long are they? Remember, we called those arc lengths, right? And so now we want to get inside of the circle. And say we wanted to like paint the inside of a circle. We wanted to cover the entire inside. How would we do that? And so again, this is not something that should be brand new to you. You should have seen some portion of area of a circle prior to getting here. But if you haven't, here's your recap. Okay, to find the area of a circle, we're just going to use pi times the radius squared. So in this example over on the right, we have two wrestlers on a circular wrestling mat. Okay, and they're telling us that the diameter of this wrestling mat is 32 feet long. So again, I know that because 32 is centered right on the circle. If I was claiming that the radius is 32, it would probably be over here somewhere, centered on the radius. Right? So I'm going to say in this case that the area is pi times, and it looks like a radius, because I need r, would be 16 squared. Okay, so 16 squared is 256, right? And so again, I'm going to leave this in terms of pi. I'm going to say this is just 256, okay, pi. Okay, and now that I'm talking about area, we're going to call this square feet. So I'm going to say feet squared, okay? So I would claim that the area of this wrestling mat is 256 square feet. Again, nothing too crazy, nothing brand new. We know how to do those, right? So again, the big thing for us is, well, let's say I wanted to take this wrestling mat and I wanted to make it many different colors, and maybe I wanted to say this little section right here, okay, between these two radius lines, I want to be blue, and I want to find the area of just that little section, right? So first of all, that section is called a sector, okay? And so here is our definition and how we name sectors, right? A sector of a circle is a region that is bounded by an arc and two radius lines at the endpoints of the arc, right? So we're trying to kind of do the same thing that we did with arc measure, where we're drawing two radius lines, right? So you can again see in my picture here, I'm going from P to S, that's a radius line. I'm going from P to R, that's a radius line. And at the ends of these two radius lines is R and S, so I'm also including the arc that goes from R over to S. Okay, and then if you notice this little space in here, this is what I'd be trying to paint if I was trying to, cover just a section of the circle, right? And so we name a sector the same way that we name the central angle. So the central angle here would be from R to P to S, so I just call this sector RPS, okay? So if we wanted to find the area of this, we're going to do something very similar to what we did with arc length. So just to recap arc length before I actually show you the area of a sector, we said arc length. If I just cared about how long this little RS line was, like we did in the last video, I'd say how many degrees, which I'm going to say measure, okay, measure over 360, right? So how many degrees is this central angle, aka this arc, because they're the same, right? This measure, and we said pi d goes here because we were trying to measure the outside of the circle, and this is the circumference formula, which finds us the outside of the circle. We're going to do the exact same thing, but instead we're not measuring the outside of the circle anymore, so I'm going to get rid of this, right? I'm going to get rid of this little extra writing too. Instead of that, we're going to measure the inside of the circle. Well, the inside of the circle is the area, aka pi r squared. So to find the area of a sector, that's exactly what we're going to do. We are going to find the measure of the arc, which, remember, measure is the number of degrees out of the whole 360 that the arc represents, okay? And then we're going to multiply that by pi r squared, because we're kind of saying what part of the entire area does this sector represent. And so this is the part, and this is the entire area, and when we multiply those together, that gives us the area of the sector. So let's just do one example of that, okay? And we are going to find the area of this little sector, which again we call this GPH, because that's how we would name the angle, right? So they tell us that the angle is 72 degrees, right? Or the arc is 72 degrees. So we're claiming that 72 out of the 360, okay, is being used up by this arc GH, okay? We're going to multiply it by the area of the entire circle. So again, this is kind of saying this is the part I want, and then in this space we're going to write the entire circle, so it's this part of this whole. So I'm going to say pi times, and they're saying 15, well, 15 squared. That's pi r squared. So again, 72 out of 360, okay, is something that reduces nicely. Okay, it's 2/10 or 1/5. So I'm going to say this is really 1/5 and then this is 225 when I multiply 15 times 15, 225 pi, right? It says leave your answers in terms of pi, so we're going to do just that. And again, this is something 225 divided by 5 is equal to about 45. So I'm claiming that the area inside here is 45 pi. And again, I'm going to use area units because this is measuring the inside, so we would say centimeters squared. Okay, so I'm not going to go through any of these other examples because they're pretty much the same thing. Right? And you get the idea. We're really using the same formula that we used for finding the length of an arc, and we're applying it to area because we're still finding a section of the whole circle, right? And then applying it to that particular area or circumference formula.